Alright, welcome everybody. Today we're going to start off with our target practice. We're just going to go over it real quick. So the first problem says graph the equation 3y plus 4x equals 12. Now I'm trying to get y by itself here, so I need to get rid of the 4x. To do that, I'm going to subtract 4x from both sides. Subtract 4x. So I have 3y equals, well, I can't combine 12 and 4x because one has an x and one doesn't. So I have negative 4x plus 12. Divide everything by 3. So we get y equals negative 4/3 x plus 12. So now if I wanted to come up with x's and y's, I could. I'm going to need to graph this. So I'm just going to do like 0, 1, 2. Actually, instead of 0, 1, 2, I'm going to put 0, 3, 6. So if I wanted to make my graph here, I'm just going to make a quick little graph on my graph paper here. So if I put 0 in for x, that'd be 12 divided by 3. I missed that. That's positive 4. If I put 0 in for x, negative 4/3 times 0 is 0, plus 4 is going to be 4. Negative 4/3 times 3 is going to be negative 4, plus 4 is going to give me 0. And then negative 4/3 times 6 plus 4 would give me negative 4. So what we gotta do first then is look at 0, 4. So 0 on the x, 4 on the y, 1, 2, 3, 4. And 3, 0, 1, 2, 3, 0. And if I go to 6, go down 1, 2, 3, 4, negative 4. And there is my not so straight line, but you get it. It's supposed to go straight down like that. It's a terrible line. Sorry, guys. Here we have x equals 2. So if I create my graph, and I have x equals 2, then that means that I need to go over to my 2, 1, 2, x equals 2 is right there. Now, I don't have any y's, so it can't touch the y-axis, so it's just going to go straight up and straight down. X equals 2 is a vertical line going straight up and straight down. Alright, today we're continuing on graphing linear equations, so let's get right into it. 4.2b, graph linear equations. First thing we got to do, we always need to solve for y. So this is what I'm trying to get by itself. I have a positive 3x, so I'm going to subtract 3x to move it over to the other side. So I have 2y equals, I can't combine negative 3x and 8, so I have negative 3x plus 8. So, divide by 2, divide by 2, and divide by 2. So we have y equals, I can't divide negative 3 by 2, so I'm going to keep that. Negative 3 over 2x plus 8 divided by 2, which gives us 4. So if I wanted to graph this, I'm going to have to come up with some x points. So I'll make my table right over here. I'm going to go 0, 2, and 4. So if I put 0 in for x, I get 0 here, plus 4 gives me 4. If I put 2 in, that means I get negative 3 plus 4, which gives us a positive 1. And then if I put 4 in, I'm going to get a negative 2. So I have 0, 4, 0, 1, 2, 3, 4, my first point, 2, 1, my second point, and my third point is at 1, 2, 3, 4, down 1, 2. Just gotta connect my lines, or connect my points. And I have a negative line. Here I have x equals 2. So we don't have any y's, so we know it can't touch the y. So I'm going to go over to x equals 2, which is right here. Now the only thing I can do, because it can't touch the y, is just make a straight up and down line. X equals 2 is a straight vertical line at x equals 2. Okay, let's go on. Now we're going to graph a linear function with a restricted domain. So what restricted domain means is that we can't go a certain spot. So if you're restricted from going somewhere, you can't go anywhere, or can't go there. So it says graph the function y equals negative 1/2 x plus 4 with a domain x that is greater than or equal to 0. Then identify the range. So if I make a table, my range, or my domain, or my x, cannot be less than 0. It has to be greater than or equal to 0. So I'm going to put 0, 1, 2, 3, 3, and 4. So now I just need to solve this for y. So if I have 0 times negative 1/2, that gives me 0, plus 4 gives me 4. Negative 1/2 times 1 gives me a negative 1/2, plus 4, so that gives me 3.5. Negative 1/2 times 2 gives me a negative 1, plus 4 gives me 3. My pattern here is it's going down by 0.5. The next one's going to be 2.5, and the last one has to be 2. So if this is the domain, this has to be the range. Plot the points. Alright, so I'll start at 0, 4. So I go 0 on the x-axis, but I go up 1, 2, 3, 4 on the y. 1, 3.5. 1, 1, 2, 3.5. 2, 3. 1, 2, up 1, 2, 3. 3, 2.5. 1, 2, 3. 1, 2.5. And 1, 2, 3, 4, up 2. Now, because I made a mistake here. Step 3 says connect the points with a ray because the domain is restricted. our domain can't go anywhere that's less than 0. So my mistake here was I made this line too long. This line cannot go past 0. So it's only going to go in that direction, but I can only make an arrow going this way. My point stops right there because this is the restricted area. We can't go there. Last part says identify the range. Well, our range then is 4, 3.5, 3, 2.5, and 2. Next it says graph the function y equals negative 3x plus 1 with a domain x is less than or equal to 0. Then identify the range. So if I'm going to make my table here, my x has to be less than or equal to 0. So my first number is I'm going to put 0. Then less than 0, put negative 1, negative 2, and negative 3. So now I have negative 3 times 0 plus 1. Negative 3 times 0 is 0, plus 1 is 1. And negative 3 times negative 1 plus 1. Negative 3 times negative 1 is 3, plus 1 is 4. Negative 3 times negative 2 plus 1. Negative 3 times 2 is 6, plus 1 is 7. And finally, negative 3 times negative 3 plus 1. Negative 3 times negative 3 is 9, plus 1 is 10. So, we have 0, 1 for our first point, negative 1, 1, 2, 3, 4 for our second point, negative 2, 1, 2, 3, 4, 5, 6, 7 for our third point, and negative 3, 1, 2, 3, up 10 for our last point. Now remember, our line can't go past 0, so we're just going straight up with a ray that keeps on going. But it can't go past 0 because this is the restricted area. Here we're graphing the function y equals negative x plus 3, but this time our domain is between negative 2 and 4. So, if we make our table, our domain, or our x, can only be between negative 2 and 4. So we can have a negative 2, we can have a negative 1, we can have a 0, we can have a 1, 2, 3, and 4. So if we have negative x plus 3, if I put in negative 2, my x was negative, so I keep the negative. Negative 1 times negative 2 gives us 2, plus 3 gives us 5. Negative times a negative 1 plus 3. Negative 1 times negative 1 gives us a positive 1, plus 3 gives us 4. Negative times 0 plus 3, so negative. Get negative times 0 is just 0, plus 3 is 3. So it looks like I'm going down by 1, so my next one should be 2, and after that should be 1, 0, and negative 1. Now be careful when we graph this, because we're going to go to negative 2, 1, 2, 3, 4, 5. That's our first point. Then negative 1, 4. Then 0, 3. 1, 2. 2, 1. 3, 0. And 4, negative 1. Now the reason we have to be careful is that this stops at the edges, or the last dots. So our line only goes from there to there, because we said we have a restricted domain, so anywhere past here is restricted, and anywhere past here is restricted. So it's only a line segment this time. Lastly, our range is 5, 4, 3, 2, 1, 0, and negative 1. Alright, a couple more slides here. This one says the distance d in miles that a runner travels is given by the function d equals 6t, where t is the time in hours spent running. The runner plans to go for a 1.5 hour run. Graph the function and identify its domain and range. So it looks like on here we have 4 separate spots that we can put on our table. If he's going for a 1.5 hour run, we know he's at some point going to start at 0. Then he's got 3 more spots. If we do 1.5 divided by 3, we're going to get 0.5. So if I put 0.5 here, maybe 1 hour here, and then 1.5 after that, now we're doing 6t. So here we'll have 6 times 0, which gives us 0. 6 times 0.5, which is going to give us 3. 6 times 1, which gives us 6. And 6 times 1.5, which is going to give us 9. So we only wanted to go on a 1.5 hour run, so we have to stop there. We're done there, because he's done running. So our first one is 0, 0. So we have a dot right there. Then 0.5, he goes up 1, 2, 3. At 1, he goes up to 6. 3, 4, 5, 6. And finally at 1.5, he goes up to 9. So he starts at 0 and ends at 1.5. We just have a line segment. So if you look down here, it says identify the unspecified domain or range. From the table or graph, you can see that the range of the function is 0 is less than or equal to d, which is less than or equal to 9. And that makes sense because we started at 0 and ended at 1.5. Alright, for this one it says, for gas that costs $4 per gallon, the equation C equals 4G gives the cost C in dollars of pumping G gallons of gas. You plan to pump $20 worth of gas. Graph the function and identify its domain and range. So we have C equals 4G. We know that we only have $20, so $20 is going to be our cost, equals 4G. So I'm going to divide this by 4 just to figure out how many gallons we can put in there. So we'll have G equals 5. So we can only put 5 gallons into this tank. So we'll have our table, X and Y. Looks like if we put 0 gallons of gas in, we're still going to have $20. If we put 1 gallon of gas in, we're going to have 16. If we put 2 gallons of gas in, we're going to have 12. If we put 3 gallons, 8. 4 gallons, 4. And 5 gallons of gas, we'll have $0. $0 left. So if I'm going to go up by 2's here, I'm going to go up by 2 so I can fit this all on my graph. My x's, actually I'm going to go up by 1's. So 1, 2, 3, 4, 5, 6, 7, I'm going to stop there. The y's though, I'm going to go up by 2. So I'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So at 0 gallons of gas, I still have $20. At 1 gallon of gas, I have $16. 2 gallons, I have $12. 3 gallons, I have $8. 4 gallons, I have $4. And 5 gallons, I have $0 left. So, my graph goes from 0 to 20, or 20 to 0, and that is all it can go. Finally, we're going to graph one last graph. It says graph x minus y equals 3 and 2x minus 2y equals 6 on the same graph. So the first thing we got to do is find out x minus y equals 3. If we solve that for y, we have a negative x. We get negative y equals negative x plus 3. Divide everything by negative 1. We get y equals x plus negative 3. Or y equals x minus 3. If I wanted to graph this line, I'm going to make a table. I'll put 0, I'll put 1, and I'll put 2. So 0 times, or 0 put in for the x minus 3 gives us negative 3. 1 minus 3 gives us negative 2, and 2 minus 3 gives us negative 1. So our first line is 0, negative 1, 2, 3, 1, negative 2, and 2, negative 1. So if I make that line, it'll look like that. Now my second line is 2x minus 2y equals 6. I'm trying to get y by itself, so I'm going to subtract 2x from both sides. We get negative 2y equals negative 2x plus 6 divided by negative 2 for everything. Y equals negative x. Oh, sorry, not negative, because two negatives make a positive. So x, and 6 divided by negative 2 is negative 3. So we have x minus 3. So we got the same equation. So what's going to happen with our graph? Well, it's going to look the exact same. So instead of two different lines, we're going to have two lines on the same line. Alright, that's it for today. Good job today, guys. Thanks for listening. See you tomorrow.